Today we're going to talk about heat transfers. I have here a diagram demonstrating the three states of matter: solid, liquid, and gas. Let's pretend that this solid is an ice cube. In this beaker we have liquid water, and in the very bottom in this beaker, that liquid water is turning into water vapor, or essentially a gas. In order to change from one state of matter to another, whether we're going from a solid to a liquid and a liquid to a gas, or the other way, from a gas to a liquid and a liquid to a solid, it's all about heat. Let's start with a solid. We've already talked about how water freezes at 0 degrees Celsius. In order for me to turn it into a liquid, I have to add heat, which is represented by this red arrow. So imagine the red arrow is me adding heat. The freezing point of water is 0 degrees Celsius. Inside this beaker, I have water in a solid form, in an ice cube. If I take out the temperature, or the thermometer, you can tell at 0 degrees Celsius, water freezes. However, if I continue to add heat to this ice, it will start to melt. At 0 degrees Celsius, ice melts if heat is added to it. Once I start to add heat to this solid block of ice, at 0 degrees Celsius, it begins to melt. We call this our melting point. After the ice, the solid state of matter, melts at 0 degrees Celsius because heat is continuing to be added. In this case, the temperature of the room is warming it up. It is now turned into a liquid state. Once it's fully melted, it's in its liquid state. If I continue adding heat to it, eventually it will turn into a gas, or water vapor in this case. In order for water to turn into a gas, it has to reach 100 degrees Celsius. 100 degrees Celsius is the boiling point of water. So after the block of ice has melted, we place it on a hot plate to continue to add heat to it. In this case, we're adding more heat. That water that was liquid now begins to turn into water vapor, which is a gas. In gas you can't see, but you can see the steam rising from it. Above that steam, that's when it becomes a gas, which you no longer can see. Now let's go the opposite direction. Let's say I have a water vapor. If I want to turn water vapor, a gas, back to a liquid, I have to remove heat or subtract heat from it. In this case, I'm using a blue arrow to demonstrate removing heat. So if I remove heat from this gas, the water vapor, once the temperature is low enough, it becomes a liquid again. In a liquid form, in order for me to turn it back into a solid, or ice, I have to continue removing heat. In its liquid form, once it reaches 0 degrees Celsius, if I continue to remove heat, it will freeze into a solid state of matter. So 0 degrees Celsius, if I'm removing heat, 0 degrees Celsius becomes the freezing point of water. So if you look at this diagram, at 0 degrees Celsius, two things can happen to water. If you're adding heat at 0 degrees Celsius, it becomes the melting point of water, where it goes from a solid to a liquid. If, however, you're going from a liquid to a solid, you're removing heat or taking heat away or cooling, at 0 degrees Celsius, it's the freezing point of water. So water both freezes and melts at 0 degrees Celsius based on whether you're adding heat or removing heat.